By combining the basic limits with the following operations, you can find limits for a wide variety of functions. Now, this looks complicated at first blush, but it's really not. If you can accept that the limit of this function as x approaches c is some number L, that's the trend in y for this function, and as we take the limit of g of x, another function, as x approaches c, we get another constant value, some value k. These are two different numbers. Then we can talk about scalar multiples. The limit of this function as x approaches c. Now, notice this function is the function times a constant. Well, it means just find the limit of f of x and multiply it by the constant. In other words, we could really pull this constant out in front, find the limit, and then just multiply that limit by b. Hopefully, that's kind of intuitive at this stage in your math career. Sum or difference. If I take the limit as x approaches c of some function plus or minus some other function, it's simply going to be the limit of this one, L, plus or minus the limit of this one, K. Again, I would hope that that's rather intuitive to you. Similarly, the product, the limit as x approaches c of some function times another, is simply the product of their limits. What's the limit of this one? L. Multiply it by the limit of this one, K. Likewise with the quotient, the limit of x approaches c of this function f of x divided by g of x is simply the limit of the numerator divided by the limit of the denominator. And for the power, if I have the limit of f of x to the n as x approaches c, now this is a function raised to a power, well, just find the limit of whatever's in the parenthesis and then raise it to that power. So it's fairly intuitive, I think. Let's take a look at these properties in action. First one, the limit of x squared as x approaches 4. This is simply direct substitution, and I'll get 16. I'm going to write ds for direct substitution there. Now, in the second one, I use the scalar multiple property. So this limit of 5x as x approaches 4 is the same as 5 times the limit as x approaches 4 of x, which this part, use direct substitution, will give us 5 times 4, or 20. And what are we using here? The scalar multiple property. How about this one? Tangent of x over x, we're going to take the limit as x approaches pi. Well, according to our quotient property, this is the limit as x approaches pi of tangent x over the limit as x approaches pi of x. Well, that is tangent of pi, if I use direct substitution, and pi there. Well, we know if you follow your unit circle, what happens at pi? Well, that's y over x over here, which is 0 over 1, which is 0. 0 over pi will give us 0. That's our quotient property. In our next one, again, we're using direct substitution. This becomes the square root of 9, which is 3. Isn't it great when direct substitution works out? And this last one at the bottom, x cosine x, we can use the sum and, we can use the product property, which says this is the limit as x approaches pi of x times the limit as x approaches pi of cosine of x, which of course will give us, if I use direct substitution, I'll get pi times cosine of pi. I use direct substitution twice. Now I know cosine pi is -1, so I get negative pi. Isn't it great to be a second semester student and know immediately cosine pi is -1? For this last one, I can use both the sum and the power properties. This is going to be equal to what? The limit as x approaches 3 of x plus the limit as x approaches 3 of 4. And we're going to raise that by the power property to whatever our power is out here, which is 2. Well, direct substitution will give me 3 plus, if the function is y equals 4, when we substitute in a 3 there, we still get 4, which of course will give me 7 squared, or 49. So I'm using two properties there. I'm using the sum property and the power property, but it's intuitive, it's fairly easy.